In this video, we're going to be looking at graphing systems of linear inequalities. So this is going to be really similar to what we did in our last lesson when we were just graphing a single linear inequality. But now we're just going to have two of them. So our first step is going to be to graph each inequality on the same graph. And then what we're looking for is we want to find the common shaded region. In other words, where they overlap. And that is because all these points in the region are solutions to the system. So everywhere where the shadings overlap, any point in that region is going to be a solution. And remember that points on the solid boundary line are solutions to the system, while points on the dashed are not. And we'll see some examples of that later on. But let's get into some examples of graphing these systems. Okay, so my first one, I have y is less than or equal to 3, and then y is greater than negative x plus 1. So I'm going to start with graphing y is less than or equal to 3. And so here, remember, when I have y, that is what we called hoi. And so that means it's going to be a horizontal line at y equals 3. So I'm going to go to y equals 3, and it's going to be a horizontal line. But first I need to see, is this going to be solid or dashed? Well, I notice that there's the line underneath that's less than or equal to. So when I see that line, that means it's going to be solid. And now I need to determine whether I'm shading above or below. Here I have less than or equal to, and so that means I shade below. Okay, now my next one, I have y is greater than negative x plus 1. So this one's already in slope-intercept form for us, so we can go ahead and begin our b. So begin at our y-intercept. So my y-intercept here is 1. And then my slope here is going to be negative 1. So remember, whenever there's not a number in front of x, there's really an imaginary 1 there. And I can think of that as negative 1 over 1. So that means I want to go down 1 to the right 1. And then I can also go the opposite direction by going up 1 to the left 1. And now to see whether it's solid or dashed, I see that this one's strictly greater than, so that means that this one is going to be a dashed line. And so it kind of helps if you do points across the graph, so that kind of leads your dashed line. And now I need to determine whether I'm shading above or below. Here, this is greater than, so that means I want to shade above. And so that means that all of my solutions are here in this shaded region. I like to go ahead and just make that a little bit darker so it's really obvious where my solutions are at. And so that means that any point in this shaded region is going to be a solution. So like for instance, 3, 1, that's a solution. This point over here is a solution. Any point on this solid line is a solution. The only one that's not going to be is any point on this dashed line. Okay, let's try another one. So this one I have 3x plus y is less than or equal to 3. And so this isn't in slope-intercept form. And so there's a couple of different ways that you can go about doing that. You could use it is in standard form, so you could find your x and y intercept. I'm going to go ahead and just switch it to being in slope-intercept form because this one's a little bit easier to go ahead and just do that. All I need to do is move my negative 3x. And so I get that y is less than or equal to negative 3x plus 3. And now I can go ahead and graph that. So my y-intercept's at 3. My slope is negative 3 over 1, so I'm going to go down 3 to the right 1. And then up 3 to the left 1. I have that line underneath that's less than or equal to, so that means this one's a solid line. And it's everything less than this, so that means I want to shade below. Because remember, for this less than or less than or equal to, you're going to shade below. Now I need to graph my second one. This one is really close to being in slope-intercept form. I just need to move that 1. And so when I do that, I get that y is greater than or equal to x minus 1. So my y-intercept here is -1. And then my slope here is 1 over 1. This one's another greater than or equal to, so that means that this one's a solid line. And then I want everything bigger than that, so that means I'm going to shade everything above. And so that means my solutions are everything in this common shaded region. So it's going to be everything in here. Okay, go ahead and pause the video. I want you to go ahead and try doing number 3. So the answer you should have gotten was something that looked just like this. Now for this last one, I have to do a little bit more work in the front end because I need to change both of these to being in slope-intercept form first. So I'm going to fix my first equation first. So I need to add 3x to both sides. So I want to get y by itself. And then I'm going to divide both sides by 2. And remember, when I'm doing that, I need to divide every single term by 2. So that means I get that y is greater than or equal to 3/2 x plus 1. And so this tells me that I want to shade above because it's greater than or equal to. And it's going to be a solid line because I have that line underneath it. So I'll start at my y-intercept 1. And I want to go up 3 to the right 2. And then down 3 to the left 2. And then I'm going to shade everything above it. Now I need to do the same thing with my second one. This one's a little bit easier to change into slope-intercept form. I just need to add that 4x to both sides. And so when I do that, I get that y is less than 4x plus 3. So my y-intercept is at 3. And my slope means I want to go up 4 to the right 1. And then I can also go down 4 to the left 1. And now this one tells me that I want to shade below, and I'm going to have a dashed line. And then shade everything below. And so this one has a really small shaded region. It's just everything, or overlap region, it's just everything right there.